So welcome everyone. Welcome to those who are here and to those online joining us via Zoom, to those watching on YouTube and those watching later, if you're watching it, hopefully. So this seminar presents results from the last 3 years of a project funded by the Lithuanian Research Council. So we acknowledge the funding, and it was run by the Nature Research Center in Lithuania. And the project was focused on understanding on sustainable inland fisheries and the status of inland ecosystems. And of course, I have to acknowledge a very large team that worked in this project. There is a lot of people who were involved in this. If you want to know more about the team and about our research, I encourage you to go to our website, sif.lt, sustainableinlandfisheries.lt, and it will be updated in the next month or two. So if you don't find information you need, please come back later. There might be more information that you might find useful. And when we talk about inland fisheries and inland ecosystems, there is one big aspect that we need to pay attention to, and that is recreational fishing. When we started this project 3 years ago, we thought, well, we probably need to consider recreational fishing. And the more we researched it, the more we understood that this is really a very big force. Ecologically, it's a very important force and it has a big impact on ecosystems. But it's also an amazing opportunity for data collection, for societal engagement, because there are so many people who are actually watching these ecosystems, interacting with them. It's also a very important force economically. I mean, it's a big impact for the economy, and people are buying gear and engaging. There are a lot of companies involved in this. And also, something that is not very often acknowledged is that it's also an important source of fairly sustainable food. I mean, the fish grown in our lakes is probably one of the most sustainable sources of protein that we can find. Well, and finally, it's of course important mentally, spiritually, emotionally. People spend time in nature enjoying fishing. So, but despite all of these aspects, research into recreational fishing is still extremely limited. We see various departments have the whole groups of people working on commercial fishing, yet there are very few people working on recreational fishing. And that is because it's really hard. However, new technologies, new tools are opening new possibilities. And it also opens us a possibility for a more active societal engagement. And there are a lot of anglers out there, so we are hoping some of you are watching this online and you will get inspired and will get engaged with scientists into your local program to participate in citizen science activities in data collection. So while some people are still coming, I would like to invite our first speaker, Robertas Urbanavičius from our company Thrust. This has been an extremely successful and very pleasant collaboration where we developed a method to count anglers, to count recreational fishing effort, which is one of the biggest challenges really, because we actually don't know how many anglers are there.
Hello, my name is Robertas Urbanavičius, and I represent company Aerodiagnostica, or we are operating under trademark Thrust. So who we are? Actually, we are a company. We are developing our own unmanned aerial vehicles, UAVs. We are collecting data. We are working with sensors. We are analyzing this data. And shortly, our experience comes from year 2013 approximately. From this period, rapid development of UAVs in Europe, in the world started. And during this last active period, we developed something like 20 our own UAVs, which could be used in different sectors, starting from inspection of aerial matches, such like infrastructure, nature protection, forests, etc., etc., etc. So during these flights, we made something around 35,000 kilometers only logged during projects. Of course, we flown much more kilometers during tests, calibrations, reflights, etc., etc. Shortly, how accurate and efficient we can do this. We are flying and we are using different types of UAVs, starting from multicopters up to big size unmanned aerial vehicles, UAVs. We are capable to carry up to 8 kilograms payload systems, cameras, etc., etc., etc. It's very important to note that in European airspace, if we are flying in civil airspace, we cannot exceed 25 kilograms MTOF, maximum takeoff weight. What is important? Talking about anglers, it's not so easy to collect data. Typically, standard approach is to use DJI or Untitled Chapter to collect data, to analyze this. Theoretically, it's possible. Practically, when during one flight you need to make around 100 kilometers mission distance in different climate conditions, we are operating from summer to winter, from plus 30 up to minus 20 degrees. It's not so simple, but it's done. Oh, dead. Sorry. So shortly about different technologies. We tried to compare 3 different technologies which could be used for a collection of data for counting of anglers. First of all, most popular multi-rotor UAVs. Multi-rotor UAVs, they're small, they're reliable, everything is reliable with them, but biggest disadvantages, short distances, and limitations related with the payload, cameras, data transmission, other aspects. We are from this sector. We decided to use fixed-wing UAVs, and here, depending on technology, we can fly up to 8 hours if we are using mechanical motor, but we don't like this because it's audible. Its acoustic signature is so high. So this is a simple explanation, which we moved to electricity, to silent flight, and this is a big advantage. What is interesting, during our data collection, sometimes anglers who knows that we will fly, they didn't see us. They don't know that they are counted. It's interesting, but in reality that is such. One more competitor we like and dislike this, it's manned aviation. Manned aviation has some advantages, but unfortunately it's extremely expensive entertainment. Plus, it's not so simple to fly safely in low altitude. In our case, when we are flying in a 50-70 meters altitude AGL, above ground level. So it's really low. It's necessary to take into account that height of trees, in some cases in Lithuania, we don't have tall trees, but 30 or 35 meters, we saw such situations. Technological aspects. What we need to collect data? We need UAV, we need sensors, we need a ground control station, or at least simple computer with aerial. That's all, simple. Anyone can do this. It's doable. Short about our main competences. We are working with RGB cameras. This means standard cameras, day vision cameras, plus thermovisors. In such situation, thermovisors, even in this project, were used if in foggy conditions, in light rain, in situations when it's dark or it's semi-dark. Standard RGB cameras in such situation are collecting really low quality data. Pixels are very high and it's not acceptable. But combining these two flows of data, it's possible to achieve more or less acceptable results. And these results could be used for analysis later, but I will talk a bit later. One more interesting direction where we think we have some experience. It's lidar sensors, and it's absolutely different type of data collection and data which is collected. It's 3D point clouds. But about this, we will talk with specialists who are working with the forests, with other directions, because for counting of anglers, we cannot use this time. It's not acceptable. Different technology. Few aspects related with territories. We covered 3 territories during this project, and the territories are like, first of all, it's Kaunas Water Reservoir. We cannot cover all area, because this area is related with safety. Too high activity of traditional aviation is here. So local civil aviation administration gave us a ribbon somewhere here, and we covered 2/3 of Kaunas Water Reservoir, but it's quite a big task. It's not doable with standard copters. We cannot do this. Distance is quite big, plus meteorological conditions in surrounding areas near when it's forest, lake, water, land. In such situation, you can expect really complex turbulence, and unfortunately, standard copters are using too much energy, and this is one more additional argument why we moved to our construction fixed-wing UAVs. It's technological aspects again. Another area we covered 2 lakes, Duse and Metelys, in the Lazdijų region. It's quite interesting area again. It's not standard area. It's interesting that in winter time meteorological conditions are not so. I'm not a meteorologist, but for specialists in the field, it should be interesting. For example, this lake is covered by ice. This one not. Why? Nobody knows. And different conditions, different quantity of anglers, different type of catching, etc., etc. One third area where we collected data, it's Siesartis and Rudasa lakes. Very complex trajectories. Again, surrounding terrain is interesting for us. As I mentioned, we were flying in 50-70 meters altitude, and there were situations when we need to play with trees, with infrastructure. Not so simple, but doable. Shortly, typical conditions how these water areas with anglers were examined. We are flying typically with low altitude, which I mentioned. Next aspect, speed. Speed is around 50-60 kilometers per hour. It's air speed. In real life, sometimes we met heavy wind conditions up to 20 meters per second, and in such situation, we observed situations when air speed is around 18-20 meters per second, but ground speed 2-3 meters per second. And imagine situation: your plane is somewhere 15 kilometers from operator, conditions are changing drastically, and you are flying with 2 meters per second velocity. Not so simple, but doable. So returning back to missions, we made more than 100 missions, official missions. If to add testings plus calibration, plus in any project there are some mistakes, it's necessary to repeat. We made more than 200 official missions. All missions were made fully legally according to EU regulation. Few words about planes. Planes during project we tested 4 or 5, I don't remember exactly, different types of fixed wing planes. Finally, we choose our Silva B 3 meters wingspan plane, which could stay airborne around up to 2 hours. In each project, independently, you need, for example, 1 hour for mission, you need to have reserve. And we are lucky. We never had outlandings. It's 100% takeoff and landing success rate. But UAV operators should be careful, because in real projects, in real conditions, different situations appear, and you must be prepared. Next aspect, sensors. During tests, we had up to 5 RGB cameras plus 2 FLIR thermovisors. There were situations that we have up to 7 cameras during one flight. Just for better understanding what is good, what is bad, video cameras plus they were making shoots, and the quality of data resolution was around 10 centimeters per pixel. It was reduced because too high quality of collected data creates a really heavy task for analysts, for analytical part. One of interesting conclusions, we are making around 20 square kilometers per hour. It's covered area. Of course, it depends. It's related with trajectory of light. It's related with geography, with many aspects. But this is minimal efficiency which was achieved during project. Shortly about some findings which were identified during our projects. It's CONUS artificial sea, and here you see different colors, different points. All these points were identified automatically. Geolocation was extracted after flights, after analysis. And conclusion is such that the biggest activity in CONUS reservoir was in early summer, in late autumn, and it's in winter. It's ice anglers who are sitting on ice. So 3 very visible points, very visible periods when fishermen, anglers are active. Other lakes are not so active. For example, CSRTs and Robertas, our analysts identified this as a low stable activity. Each flight we see up to from 7 to 11 anglers, and the biggest amount of anglers are sitting in boats, single boats, double boats. Interesting situation in the Dusemetelis. In Dusemetelis, we lost some data, we lost some activity, because during this winter, as I mentioned, I'm not specialist of ice covering, but half of winter, this lake was only partly covered by ice. I don't know why, but it's interesting phenomena. Very big activity in winter time in this lake, and all these anglers mainly were on ice. Safety. It's a very important aspect when we're talking about UAV flights, especially today when new rules are actually they are implemented now, and we need to keep these rules very strictly, because it's safety. We are flying in the same airspace together with commercial airplanes, paraglider pilots, amateur aviation, etc., etc. So safety is very important. How to identify who is legal, who is flying legally, who is not? If we are talking about BVLOS beyond the visual line of sight flights, which flight could be identified as beyond visual line of sight flight? If you don't see visually plane, it's beyond visual line of sight flight. Of course, you have information, telemetry data, etc., but visually you cannot control your UAV, and absolutely different rules are applied. So licensing is needed. Next aspect, coordinations with different organizations, especially in situations when you're applying near borders with non-friendly countries. Everything is doable, everything is possible, but there are some rules. You need to put a transponder as a standard commercial plane. Anyone can see your flight, and this is required if you are collecting data near border, for example, even in civil airspace. Next aspect, NOTAMs, Notice for Airmen. It's legally accessible data. You can open a CAA webpage and you can see how many active NOTAMs are issued for BVLOS, beyond visual line of sight flights, for UAV users. Today we have 5 active NOTAMs in Lithuania. 4 of them belong to us, 5th for agro-drone company. So activity, believe me, is low, or there are some illegal actions. Example of NOTAM, which is covering Kaunas artificial lake, and as you see, everything is strictly defined, each coordinate, and we need to keep these rules. What is interesting, during the last 5 years, when this system is active and working, we are flying only legally, with all coordinations, with all possible NOTAMs or any needed coordinations. Examples of flights and conditions. It's winter, it's summer. We are flying, as you mentioned, from it's ice, as you see. We made some flights even from ice surface. It's interesting. It's a new experience. And what is necessary to mention? Were situations when we were collecting data in light snow or light rain, fog, strong wind shears. Everything is possible, everything is doable. Problem is data. Geolocation isn't so accurate, but we still have quite a good level of geolocation and data. Short about temperatures. During these projects, air temperature was from, as I remember, on logbook, from minus 15 up to 28, and later we had one day plus 33 degrees. So everything doable, everything is possible. And we demonstrated this. Most interesting part of story, and analysis. Data which is collected should be analyzed, and as you see, it's examples of library which is collected, which should be analyzed, and it's a critical and very important part for the project, because you can do this manually. You can inspect just some analysts could work. They can do something. Just jumping from page to page, from slide to slide, but efficiency is really low. One hour of data connection is related with from 1 to 2 hours of analytics, if analytics is made manually. It's plus, don't forget, it's really heavy work. And I would say it's yesterday. It's past that type of activities, and the future belongs to automatic analytics. And what is important to mention that when we are working with the automatic analytics, for example, 2 hours flight could be analyzed in less than 10 minutes. So it's time. Second aspect, accuracy and reliability. Reliability is much more higher, and accuracy is much more higher. Typically, if person can see on a video or pictures some events, for example, in our case, anglers, analytical system can do this, but people are uptight, people are making mistakes. We saw this many times. There are some situations, and in this case, analytics is much more accurate, and I'm voting for analytics, which is based on AI. Examples of analytics. We are counting. Our system can count anglers in the ships. Our system can count anglers on ice. It's a very tricky situation. As you see, it's thousands of ice holes plus boxes plus docks plus some equipment left. Theoretically, it's possible to identify, but believe me, if you're using a normal AI-based analytical solution, it's future, and the accuracy uncomparable to manual inspection. Another situation, combination of RGB camera with thermovision. It's absolutely different level, much more higher accuracy, and this allows us to avoid mistakes, plus possibility to inspect data even in night time. Here is a simple example. It's ice and anglers. Similar situation with anglers on shore. It's there are some hidden anglers. Visually, you cannot see them. Combining RGB and thermovisors is doable, and in such situation, especially in some geolocations, I would say 50% of anglers are invisible. If you are using standard cameras, RGB visual cameras, you can't identify them. They are simply hidden by vegetation, or they are sitting in bushes. Reality is such. This is example how analytics work. Two types of solutions. One solution is one situation when you're returning back, you are uploading collected data, and a supercomputer creates analytical actions. Another possibility, you can send data, and you can arrange online analytical solution. Both ways are possible. This is real projects, different angles, different locations. You see propeller in this case. It's as I mentioned, we tested different installation possibilities, different types of cameras, and believe me, it's not so simple to identify person who is one person. We are joking. One person is related with 100 ice holes. It's joke, of course, but in some cases, there are interesting situations when you didn't see any person, but you see thousands of holes, different logics, different geolocations, etc., etc. So, a few aspects which are important. Theoretically, it's really easy to collect data, but practically, you see some reflections. Different types of illumination, foggy conditions, light rain, snow. Welcome to real world. And all this data should be identified, and all angles should be counted. So we tried different installations, stable installations, moving installations, and finally, as you see, everything is doable. As I understood, I have 1 minute. Yes. Well, what is important? During this project, we tested and we created a system which works. And a really interesting experience was obtained. And currently, what we need to say that we can work in the different types of nature protection projects. We are using different types of data collection sensors. We can prepare individual analytical solution again based on AI. What else? Very prospective area laser scanning. You can inspect really big areas using LiDAR equipment. It's future, and think about this. And main conclusions, as I mentioned, more than 20 kilometers per 1 hour. During this project, we've flown more than 5,000 kilometers. System is working. RGB plus thermovision plus geolocation. This combination is really powerful and could be used for even bigger projects, such like Coronian Lagoon as example. And of course, it's possible to work and to develop interesting solutions for different types, forestry, other types of nature protection. And by then, I would like to thank Nature Research Center for invitation for us into this project. And thank you. And I'm ready. If any questions, I will try to answer. Thank you.
Thank you, Robertas. Really interesting and inspiring work, lots of possibilities. So I would like to say that we will have a Lithuanian version of us adapted more to Lithuania in the afternoon session, so you can also ask questions in Lithuanian later if we have more discussions. The question is, do we have anyone with questions online? If anyone is on Zoom that might want to ask, that's a possibility now for the online participants. But otherwise, if you have any questions you would like to mention or ask, go ahead.
Thank you.
So I have a question about, so Anglers is just one thing, right? So because of course a lot of people, we want to count, I don't know, wolves, or we want to count, I don't know, any warm objects. And also, how do you think it would work for counting anglers in the sea? Would that be something similar? I guess it's similar boats, but I don't know if there are waves. Would you need another technology?
Thank you. The question is really good. We spent a lot of time identifying anglers on moving surface, like waves. I don't remember, did we included some pictures even in Kaunas Lagoon? There are situations, really windy days and quite big waves. I would say up to 1 meter, and visually from the ear you see that activity is really big, but it's not comparable with the sea wave level. So I think everything is possible. We had yet such experience working with such type of data, but I didn't see any strategical problems here. It's just some collaboration, some experience is needed, and I think it is doable.
Because I've heard people have issues with water reflectivity, right? The waves are reflecting, and so it's, yeah. But yeah, apparently you managed quite successfully to identify anglers. The accuracy is quite high. I saw 90% or something in many cases.
Yes, and we achieved, you saw accuracy is floating from 75 to up to 95%, and average is around 85-90, so it's absolutely acceptable. Of course, there is some external influence could be expected, but my preliminary conclusion that is doable.
Yeah.
Okay.
All right. So we will. It's just a good time to go to the next presentation.
Thank you.
Thank you very much, and I'm hoping for more discussions later in the day and the afternoon. So the next presenter is Jan Kubečka from Institute of Hydrobiology in the Czech Republic, and I'm very glad that Jan could join us because you're working with a lot of freshwater research in Lipno Reservoir and also engaging with anglers. And yeah, so we are very interested to hear about your experiences, how recreational fishing assessment and engagement is going on there.
Good morning, everybody. I hope you can hear me.
Yes, we can hear you and see you very clearly.
And so we will move to the Lipno Reservoir. I will try to share my screen. Okay. And
Jan, you will have to swap the views again, display settings.
Yeah, okay.
Thanks, that's good.
Oh, it looks good now. We got into study Lipno Reservoir mainly when our anglers had some problems with their fishery. So they invited us relatively late, but anyway, because the problems appear in the start of millennium, we have now some time series of observation of the system. Many people were again involved in the study. And well, we do kind of fishery dependent stock assessment, also of course analyze the data from the anglers, which are relatively good. I will show you. Lipno is the largest water body in Czechia, nearly 50 square kilometers. It's now over 60 years old, and it has some multiple use for hydropower, recreation, flood protection, water supply, and kind of recreational fishery. There was actually a commercial fishery in the 60s, but it was found not profitable enough, so it was closed sometimes in 60s actually. So there is only recreational fisheries on this reservoir, like in practically all Czech reservoirs. But its importance is quite big. It's kind of between 8 and 13,000 people visiting the lake every year. And they make between 90 to 155,000 daily visits, which are carefully recorded actually. The lake is managed by regional office of Czech Anglers Unit. And they practically exploit both fishes which are stocked in a kind of put and take fishery that concerns mainly to the carp, which is very favored by Czech anglers, and it doesn't reproduce in the lake practically. So whatever they stock, they are supposed to catch, maybe with some losses of abundance and some gain of biomass due to growth. And also they can exploit, of course, naturally reproducing fish, which again they may some of them support by stocking. So there is quite an intense stocking program in the lake. The anglers are quite organized. Here is the example of their actually logbook. Every time you come to the lake, you have to write down that you are there. Even if you don't catch anything, you have to record your visit. And every fish that you decide to kill and take home, or take home alive, or anyway, you have to write down the species, number, and either weight or length of it. There is generally a relatively good evidence of the kind of catches and anglers exploitation. So we don't have to count them by other methods. Of course, there might be some noise in the data. Practically, if you have a license, which of course license is compulsory, then you have no motivation to hide your visits. There is no number, there is no limit on number of visits during the year or anything like that. You may have some motivation to hide some catches. So but there is some kind of system of people who check the regulations and keeping them. So there are some bailiffs that are checking, and there are relatively sophisticated actually angling rules. It's about 10 pages of rules that you have to kind of agree. In some organization, you even have to make small like exams. The main regulations are that you are allowed to fish on two rods, maybe some limitation of angles, and of course there are minimum size limits of the several species, protection period, some limits on using natural bite fish, and there are 2 protected areas where there is a complete fishing ban. Still, of course, it is possible to get way around the rules, but so like every statistics, even this has some noise probably in, but we believe that this noise is more or less constant because and relatively low. Because most people are relatively honest and then don't have any motivation to actually cheat. So here is the history of the lake in terms of angling catches. You see that it was somehow increasing as the lake developed, anglers develop, more people had time and opportunity to come, and so on. And relatively soon, carp, which is in brown, become the main catch of the anglers. But you can see that some attention was also paid to other species, and the really important species is pike perch, the green band, which has interesting history and interesting consequences for Lipno fishery. But the main biomass, remember, is in carp. Here are the pike perch catches. Lipno Lake used to be very famous in Czechia and was producing like 50%, 20% of the total country anglers catch of about 20 tons for many years. But this changed quite dramatically at first years of millennia around 2005, when the catches dramatically dropped down, as you can see, and they were waiting for them to come back, but comeback didn't happen. So in 2009 they introduced quite radical protection measures. Especially the limits on size of natural fish bait was put on 20 centimeters, so it was practically impossible to catch pike perch on natural fish. And this was on for several years. In around 2015, some of the anglers started to push that there might be too many pike perch in the lake, and they wanted to harvest it, and their lobby was quite strong, so they managed to actually achieve lifting of this ban, or partial lifting. In 2016, unfortunately, without any scientific investigations, they decreased the size limit of this bait fish. And what happened is that the catches really started to increase for a short time. But not really, they didn't reach the levels that they were used to in 70s or 90s. In fact, now, even on this without change of fishing rules, are slightly decreasing. So there is something interesting happening. It's a pity that the lake was not investigated in details in these rich years earlier. So it looks that the population now is not able to withstand the same pressure, angling pressure like it was before. But it is still a very important issue because it seems that the catches of pike perch very nicely correlate with, for example, number of visits and even this kind of tourist industry connected with fishery. We analyzed, for example, the growth rate of pike perch, and that quite clearly showed that at the turn of millennia, the growth rate of pike perch was much slower than it is now, and also much slower than it was before in, for example, 70s. So it took a long time for them to reach, for example, the legal size, as you see. Such slow growing population was not able to actually cope with the constant, the same angling pressure, and they really did collapse. It seems that they were somehow hungry in those early years. The situation is now a little bit faster. But as you see, it's not completely recovery if people would like to. Also, Asta told me to tell you a few words about the protected areas they introduced. So yes, in 2009 they set those 2 protected areas with complete fishing ban, although there is maybe some illegal fishing. On the map, you can see those 2 red dots, and we were actually investigating the bigger one, which is about 300 hectares in one bay. And we did kind of survey by standard European gillnets in all habitats of this protected bay and in some control areas of the lake, as you can see on the map, and check the results. Well, it was nothing so striking actually. When you, for example, look at catch per unit effort with percid fish. In fact, there are two main families of the fish in the lake: cyprinids and persids. With persids, you can see practically no difference in abundance. While the cyprinids were actually more abundant in those other areas of the lake. So that means that they were actually fewer of them in the protected area, and therefore normal kind of domination of cyprinids was not so strong in this protected area, and few smaller were missing. If you look at the biomass again is slightly smaller with cyprinids, but not significantly. And but there was nearly double biomass of percid fish in protected areas, and maybe a few more pike, but the numbers are very low. And if we look at the size structure of the main two main interesting percid fish, which are perch and pike perch. So with perch, there is practically no difference. Yeah, the average length was practically the same, although numbers were slightly larger in protected areas. And with pike perch, you can see that the protection plays some role, that larger sizes of pike perch in red are more likely to occur in this protected area than in those control areas. So there are a little bit more of larger pike perch, or larger pike perch are more common there. If we looked at the diversity indices, the protection area had a little bit more diverse community with a little bit more of percid fish and lesser dominance of cyprinids. So even with the help of fishing regulations and protected areas, the situation of pike perch population doesn't seem to be still optimal. Here is the model actually coming from Asta and Egle from Lithuania, showing the possible trajectory of Lipno fishery during the years, and you see that most of points are actually in this more or less red or the yellow and red areas where the fish stock may be kind of threatened by the angling and exploitation. And we will develop actually more various models of the population. Meantime, with maybe more detailed input data. And it is quite clear that population of pike perch is not doing as good as it used to be before, and some more protection may be necessary. There are potential problems are too heavy harvesting by legal, eventually illegal harvesting as well. There is some indication that the production of pike perch food, which are mainly small fish, is not as strong as it used to be. There is also spreading of European catfish, whose status has to be investigated. And actually, in this winter, there was also some sickness, but unfortunately, somehow they were not able to actually find what was causing it. But it seems to be over. But it did some losses to the population as well. Yeah, so there will be introduced some more measures probably from 2024, because it was too late decision for 2023. So there will be a yearly limit of catch, increase of legal size, and increase of size of the baiting fish. We also are strictly now following the dynamics of this forage fish in the lake, and we will do the survey of the catfish and its interaction with pike perch next year. And as you've seen, the protected areas is somehow helping, but in fact I expect it to be kind of more significant paradise of those predatory fish. And not only myself, also anglers were expecting larger miracle, and that is actually didn't happen in this protected area. And I think this is all for short information about Lipno. Thank you for your attention.
Very similar to Kona's reservoir, what I see, and we have very similar size, in fact, almost the same angling pressure, which I'm now revealing the secret, which I will going to present in the later session, Lithuanian, and also a situation with pike perch. So if nobody has a question now, I will actually really ask. So I was very interested to hear these results about the protected areas. And somehow I was imagining that maybe half of the reservoir will be protected. Like your protected areas are very small, really. Like when you see those little circles, comparatively they are quite small. And pike perch is not like pike. I mean, they're still moving around quite a lot. So I think experience in Australia showed that even though you would have these protected areas, but then all the anglers would accumulate around them, trying to catch all these big fish. So in a way, it would increase everything that accumulates in these protected areas immediately gets catched as soon as they move out. Do you think that might have been the case?
In fact, it is true that comparing with the whole lake, the protected areas are relatively small, but in fact, many anglers were considering them too big.
Yes, I expect anglers think they're too big.
They don't like to be limited, so it was some kind of compromise. And yes, sometimes they may be fishing on the margin of the protected area, but it is not that much observed actually. So, but it is of course true that the pike perch are migrating out, and I forgotten to mention that this protected area is relatively in a kind of remote area. So not everybody gets up there. It's quite far from civilization and from the hotels where the anglers are living and so on. So it's there is some geographical limits.
Yeah.
And for example, the neighboring bay has the fish stock very similar to the protected area, even if there is angling allowed.
But it was interesting to see that you, despite the small area, you still actually saw increased biodiversity, increased number of like predatory fish, like perciforms, and a smaller number of cyprinids, which is also, as you say, is a problem in many cases, that the lakes get dominated by, I don't know, roach and other cyprinids.
Yeah. Interesting was, for example, much lower numbers of carp. I explain it by the fact that, of course, no one is feeding the fish. You know, in areas where they capture the carp, they put a lot of bait food to attract the fish, especially cyprinids, to the areas where they are fishing. And of course, this is not happening in this protected area. So that might be one of the explanations why abundance of cyprinids is lower.
Okay, 2 questions here. There's one, Harry, please. Yeah.
Yes. Further to that.
No, it's not working. You have to click this button.
Okay, further to that, if you look at, it's not just necessarily having one large area, but you've only got a couple of those areas. And quite often, as you mentioned, they're remote. So therefore, they're areas that maybe people don't worry about so much, but they may not be ideal if you're looking at a source sink situation. So if you have multiple areas and they're located in areas where the pike perch will breed quite successfully, that could be another aspect of that. Can you comment on that, please?
Yeah, I guess the question is about the location of these protected areas. Are they the best for the fish, or are they the places that are easy to implement?
Well, we might have to ask the fish for the answer, but I have to say one more thing, that Lipno, in fact, the reproduction of pike perch is not really limited, because the crop of young of the year every year is actually enormous. Practically every year. There are much more fingerlings than the lake is able to feed. And also we don't have any other reservoir in the country where there is so many actually those fingerlings in like August, September. So the input of eggs and juveniles is in fact not reproducing the not limiting the recruitment. The bottleneck is clearly the first winter. How many of them survive the first winter? And in this, actually, the protected area doesn't help too much. They need to be well supplied by food.
We have one more question here.
Hello, thanks for presentation. It was really interesting, and I'm just curious about, you mentioned that in the mid-60s you closed the commercial fishing. What were the reason beyond that?
Yeah, there were two main reasons. The one was that the reservoir fish, which were finally mostly bream, white bream, roach, were not very attractive for the customers, for the people to eat. Czechs are Czech kitchen, you might know, is tasty but not very healthy, and Czech prefer beef and pork and so on. They are not so good in eating fish. That was one reason. And second reason was clearly the kind of jealousy from anglers. Yeah, because you can understand this, that sometimes, you are sitting angling and half a day and catch nothing. And then you see the people with nets catching some fish. You get jealous. And of course, even in communist times, the anglers were a powerful lobby. So they, in fact, generated pressure to push commercial fishermen out, and commercial fishermen didn't have really too much good reasons not to abandon Lipno. So it happened relatively quickly.
I just wanted to make one comment. There is one more question here, very quick, but I was really impressed, and I wish we had that in Lithuania, where every angler has to report every trip and all the catches. That is extremely exciting, so yes. But there is one question from Linus.
Yeah, I got a question related to the disease you mentioned. You mentioned it happened during winter time, right? But was it towards spring more? And I guess your reservoir is not ice covered, right?
Oh, no. It's relatively, Asta is right that the conditions are very similar to Kaunas in many respects. Like species and size and pressure and so on, and also maybe the temperature, because it's actually 700 meters upper. So even if Kaunas is much more north, on Czech conditions, it's relatively also cold area of the country, kind of foothills, and so it is ice covered every year. Yeah, so the winters are still relatively looking like winters, despite the climate change, which is of course happening here as well, with increasing of temperature, and has a lot of consequences for fish. The problem with persids is actually they have very good reproduction, both spike perch and perch. Yeah, they produce enormous year classes, which are much more abundant than cyprinids, but they need meat during the winter. Cyprinids, if there is no, for example, zooplankton, which is very limited during all the winter, they can eat kind of periphyton or survive of all these less quality food sources, while persids really suffer during this time. So if there is no forage fish and no zooplankton. Benthos is always very limited. There is very little animal food, and that's clearly a problem.
Thank you, Jan. And we have time for a break now. And so thanks a lot for the presentation, and I hope we'll be in touch, and also about the further analysis of the pike perch and other work.
Sure, I look forward.
Should start the second part of this morning English session while people are still coming back from coffee. So we have heard about the challenges. Maybe I'll wait 1 or 2 more minutes until everybody is back to the hall. I think we can start, yes, okay. So we have heard about the challenges related to data collection from recreational fishing, and I would like to present here a great opportunity about how we could collaborate with industry, with various companies, or even with research and scientist-driven smartphone applications. And why do we need it? Because as we might have realized already, and as it's becoming increasingly clear, recreational fishing is really a big force. In the developed countries, about 1 in 10 people go fishing, at least sometimes in their life. So that's 10% of the population. And it's estimated that there are about 220 million recreational fishers, so in the world, 5 times more than the number of commercial fishers. And so recreational fishing is a public good. People are using our ecosystem, like everyone's ecosystem resource. It's rare to use wild animals as food. Yet it's a really important contribution to food supply and huge contribution to the economy and to people's well-being. But compared to hunting, for example, if we are doing hunting, people need to have licenses, and there are usually very strict regulations on reporting. Whereas with fishing, in many cases, there is very little reporting. Well, we heard that in Czech Republic there is detailed reporting, but in many other countries we have no idea how much people catch and how much they fish, and there is very little research. So people have done recreational fishing assessments using a range of methods. Some traditional methods include phone surveys where, for example, people call to a random number of people. Researchers call to a random number of people and ask them, how much did you fish and how much did you catch in the last year? So these are called various recall surveys. There are postal surveys, which are also increasingly outdated because nobody is checking the letterboxes anymore. We actually don't get letters anymore. Of course, aerial surveys, there is a lot of recreational fishing assessment is done just basically based on license sales, how many licenses are sold, and that's all we have. There are creel surveys where people go and count anglers, fix cameras. Well, now we have drone surveys. So we have these new methods, so old methods are outdated. And another new method is actually, it is a great opportunity, is that there is a huge amount of digital data now generated by various recreational fishing app companies. And this is a list of some of the apps that we are one or the other way collaborating with and who are contributing to research around the world, but there are a lot more of them actually. So in reality, we actually have millions of observations collected, like, I don't know, every day. It's very important data to study freshwater and coastal fish populations. We usually don't use this data in any way, but I would say it's a very urgently needed data because a lot of freshwater and coastal populations, especially freshwater populations, are in severe decline. Many are depleted and really highly vulnerable. There are many challenges to how we use this data from the apps, but it's a tremendous potential, so I think we need to do it. So why do we need this size industry collaboration? Of course, it's good for science because we can get data, we can get more information, but I would say it's also good for the companies because companies that are running these angling apps or somehow running angling activities, they want anglers to catch a lot of fish. I mean, that's basically, we all have the same goal. We all want for there to be lots of fish, lots of big fish. And after all, companies also are socially responsible, environmentally responsible companies. So that also contributes to that. But the big question here, which is now a big question in recreational fishing research and science, is data from these fishing apps useful? How can we use it? Because it's very different from the traditional data that we used to collect. And I will present a few examples here, a couple from our collaborators. So Christian Skov I was hoping he will give a talk by himself, but he couldn't attend today. So here are a few slides I'm sharing on his behalf. This is from Technical University of Denmark, where they have been running this electronic angling logbook, Fangstjournalen, probably not like that pronounced in Danish. So this app launched in 2016. There were the first version, some maybe initial issues. Second app version launched in 2020. They have about 15,000 registered participants, which is about 10% of all anglers that are registered in Denmark. But of course, registered, that's one thing. There's fewer active participants and quite a lot of fishing trips already reported. So the app has been supported throughout this time by various governmental bodies and so on. So this is a research organization running the app. This is not a private company. And of course, for them, the data evaluation is really essential. So you want to know whether we can say anything about the angling activity from the app. So they did one study, for example. There are lots of studies, but here is an example from one study that they did where they counted coastal sea trout fishing. And they got how many people were using the app on that day and how many people they actually observed through aerial surveys on that day. And so this correlation here is, well, it's extremely high. It's almost like seems hard to believe, but yes, it's published, it's correct. It's published in the Canadian Journal of Fisheries and Aquatic Sciences. So basically the effort measured by the app predicted the actual effort, the overall effort. And so that's encouraging and that's useful. Another a few slides is from Sean Simons, who it's a private company. They are running an angling app, MyCatch or Angler Atlas, and they are very actively engaged in science. Again, it's crazy time in Canada at the moment, so Sean kindly shared a few slides that I could present here. So the app is running, also was launched in 2018. Initially, it was focused on citizen science, where they just encourage people to log the data. But eventually, they found that it's much better to run tournaments like angling competitions, which are targeted specifically for certain questions that that researchers wanted to collect. And especially during the COVID, when all the real competitions were cancelled, the app became really popular and sort of took off. And so these angling competitions could be actually targeted for very specific questions. So one question was that they wanted to estimate how much of the tagged bass they could actually catch. So catch and release study to calculate the population size in this one lake. So this is very recent. It was just run in August 2022. As you say in the red, it's only preliminary results. But basically what they found is that the size frequencies reported by anglers, which is now in green, were very similar to those of scientific surveys in electrofishing. And also, there is this time series estimate of how many fish. So as we get more data, you can see here, through time, duration of the tournament, we get better and better estimate of the population size. So this is, and it's available to anglers through real-time dashboards. So as you log in the data, you can see how this data is being used. 53 anglers joined, caught 1,400 fish, so this is catch and release fishery, of course, and they tagged some fish, and this is the estimate of how many bass there are in the population, 11,000 approximately. Another study they did was investigating a disease that is spreading, blotchy bass bonanza, which is running now. Again, it's in collaboration with the government, where anglers are encouraged to report various sightings of this disease that they see. So if you have any questions, this is contacts of details from Sean, or contact me, I can put you in touch. And what about Lithuania? So we also have collaboration with 2 industry partners, and this really spearheaded our research. So you already heard presentation from Thrust about drone surveys, and we also are collaborating with the Lithuanian startup DIPA, which is a global company now, also trying to look at the angling activity. So first I'll present these results from the drone-based surveys about assessment of recreational fishing effort in Kaunas Water Reservoir. So this is only drone data. You saw there were 40 missions, and we applied a statistical model where we can now estimate how many anglers there will be every day during the ice fishing season and during the open water fishing season. We can see that approximately during the ice fishing season, on weekdays, we have about 50 anglers approximately. These red lines show that. But of course, on weekends, there are a lot more anglers in ice. And again, generally, there are more anglers on the weekends. So this is an approximate number of anglers in the Kaunas Water Reservoir in the area that was surveyed by drone. So this is 2/3. They couldn't actually survey the area that was closer to the town itself, closer to the airport. The next thing we did, we then correlated how is this number of anglers correlated in collaboration with DIPA with the number of users in that. And we found that actually the confidence intervals are very narrow. So we basically show that in the open water season, about 2% of anglers were using this device. And in the ice fishing season, about 50% of anglers, because it's more popular to be fished on ice. And that actually means that we can now get a fairly accurate, with some uncertainty ranges, estimate of how many angling trips were done in the Kaunas Water Reservoir in the whole area. This is published in Fisheries Research. I will not present the results because I think Justas wants to present them and surprise everyone about how many fishing trips there were. But I present some other results that was done with the collaboration with DIPA, and 2 people were instrumental in the analysis of this data, huge data set. So Fernando Mateus Gonzalez and Carl Smith helped with the analysis and data wrangling. And we had this very simple question. Everybody heard that during COVID lockdown, people had nothing to do, or they were sitting at home and they wanted to go fishing. So there's a lot of anecdotal data that there was more fishing during COVID. But how much more? Did it really happen, or are we just talking about it? Maybe people only wanted to go more fishing, but they didn't actually go more. So we tried to estimate it. Did people really fish more? And if there was a change during COVID lockdown, what happened afterwards? Maybe people started fishing more and realized they like it, and they decided to keep fishing more afterwards as well. So again, this is about to be submitted soon, I hope. I will only present some results here, but basically what we can see here, I'll try to explain these graphs. So before lockdown, this actually shows the number of anglers per municipality. Oh no, this is the number of users. This is like a relative recreational angling effort, because it's not an actual number of anglers, but sort of approximate number of users per municipality So if there are municipalities that have large number of people, like 400,000, like Vilnius, we see on the x-axis, we see that there are more of them. I'll try to point out here. I think this one points out. So this is Vilnius. Here we see how many anglers in Vilnius. And this is in, not anglers, again, relative angling effort, because this is not the actual angling effort. And this is in municipalities that are sort of sparsely populated. So what we can see from this plot, and the blue line is weekend, and the red one weekdays. Basically what we can see that there are more anglers generally in densely populated municipalities. There are a lot more on the weekends. And so this was before the lockdown. During lockdown, there definitely was an increase in fishing activity, especially on the weekends, but also during the weekdays. And after the lockdown, again, this hasn't fully, it decreased a little bit, but it hasn't fully returned to the original values. So we still have sort of generally higher fishing activity. What is very interesting is that the data in Germany is actually quite different. So it's exactly the same, but here we see in Germany, the number of anglers in densely populated municipalities is actually smaller. So people in Berlin or in some populated places don't go angling quite as much as people in Vilnius or in Kaunas. So most angling activity happens in sparsely populated municipalities. So the plots are going down, actually, these curves are going down. And another thing, of course, there are more angling on the weekend. And it's interesting, there were 2 lockdowns in Germany. And so initially that was the angling activity. During the first lockdown, definitely huge increase, almost double in angling activity. And then after lockdown and so on, it slowly decreased. It didn't decrease immediately, so people actually liked fishing. And so after the first lockdown, it was still quite high. But now we are more or less back to original values. And so this is an extremely powerful data and analysis, because until recently, well, until now, all I've seen is people are trying to estimate how angling changed through COVID, but based on license sales, based on surveys, based on questions, we can't really answer that. Here we can tell specifically in numbers how much approximately the angling activity has changed. That's just one example of a really powerful science industry collaboration. But I would say that this is only the beginning, because we really need to start collecting more information about fish sizes. This is extremely important and extremely powerful data. And if there are any anglers or any angling companies that are out there and listening to this talk, please make sure you collect data on fish sizes. Why? Because fish size is extremely important to fish and to humans. So what will, always the same mistake. What will affect the fish sizes in this population will be the fishing, temperature, food, predation, physiology, evolution. All of these factors will affect fish sizes. So from these fish sizes, we can understand how we can try to disentangle a lot of these processes. But they will also affect recovery potential, role in the ecosystem, species interactions, and after all, value to humans, because we like big fish. Anglers want to catch big fish. So value to humans, again, is very important. And also, fish sizes can tell us about population status, even from limited amount of data. Let's say we have that many observations from a certain population about the fish sizes. So we have some 3 fish at about this size and 3 about this size. There are actually models and there are theoretical predictions on how the distribution of sizes in the population should look like. And if we get limited amount of data, we can apply statistical models and we can say that this is the most likely distribution. And if we can actually say that this is the most likely population status, we can say that, okay, the population maybe should be looking like that if it wasn't fished, but it's actually looking like this. This is the way to estimate population status, which is actually quite powerful and which we can do from limited amounts of data. So I could also have to use this opportunity to introduce the app that we launched ourselves in this project. It's called Fish Size Project. It's currently available only in Lithuania, but we want to go global soon. We are not really expecting to be able to compete with a lot of angling companies because they have a lot more money, a lot more outreach. This app is perhaps more related to targeting specific scientific questions, for example, like we are hoping to go global and do some research on even market analysis. So if people can report fish in the markets, in the local markets, or underwater observations as well. So we are encouraging, you can log in with various things. So these are sort of standard things about the app. And we are encouraging divers and also just nature enthusiasts and fishers, anglers to report your observations here. I will talk a bit more about it in Lithuanian in the afternoon session. But I would like to end saying that the science industry collaboration can really revolutionize recreational fishing research because it is a huge force, and in many cases we have no idea about the effort in catches. We don't know even to the order of magnitude. It's a great opportunity, though, to collect large amounts of data. We usually say that inland fisheries, coastal fisheries are very data poor. Actually, they are not, because there are people all the time observing them. So we can learn about diseases, invasive species, and other problems. But after all, if we engage anglers in collecting data, we are also much more likely they are more likely to be informed and accepting of any management decisions because it's actually based on their own data and they can actually see what is happening. So this builds the stewardship. So the management decision rules are not coming from up. We are all learning about it and we all aim to have good population status. And we are already benefiting from data collected by companies like Google. Mobility data was essential during COVID for a lot of research. And I would like to end, because I can't not mention that another reason why we urgently need industry and science collaboration is the climate emergency, really, because we are now in unprecedented times. The temperature is going up rapidly. We don't know what's going to happen. And traditional science cannot keep up with the rapid changes that are happening. So we need all hands on deck to be able to understand and at least follow how our ecosystems are changing. So with that, I would like to thank you and take any questions if there are any. No questions now. I need to ask myself some questions. Well, there will be another talk in the afternoon in Lithuanian, so we can again talk about the app and about angle engagement. But I think if we have no questions, nothing on Zoom. Yep, there is some from Harry. Yes, we already launched it. Yep, it's available. Yeah, we created. If you try to type it, just one word, fish size project, without gaps, without spaces.
Harry?
No, it should be available. People are already using it in Lithuania. Oh, I mean, if you go to whatever App Store or Google Play or something like that, you can probably find it. Yes. Oh, I mean, on our website, yes. The website hasn't been updated. Yep, that's a usual situation. Yeah, that has to be updated soon. Yep.
I'll just take you back to the postal survey, because you mentioned that we don't use snail mail these days, and that's very true. Particularly even where I live, deliveries are only every 3 days. So, but we do use email.
Yeah.
And we do use, so I don't know of, I mean, a lot of surveys, say, have been done in Australia, were done quite a long time ago, including those telephone surveys, because that's the other thing, we don't have telephone books anymore. You know, lists of mobile contacts. So do you want to comment a little bit about using electronic media as an outreach tool, and whether you could use questionnaires through that vehicle?
Well, I actually don't have experience to it. I just think, but if I think about myself, I get so many emails. If there is something that comes in, whatever, answer some questions, it just goes to spam or delete it straight away. So it would have to be targeted somehow very clearly. The sender has to be, and I'm sure some people are doing this already. But yeah, I don't have that experience. I would like to know what is the success rate. I'm sure that that has been measured and observed. So, oh yeah, so there is some question from Greta. How are you communicating with anglers and trying to disseminate the app? Yes, that's a big question, a big issue. I mean, the question is important. We haven't, well, we had a few events. We had some things that we organized and tried to disseminate through our social media. But again, that's a big job, and probably some other private companies would say it's the whole marketing department that has to work on it. So that is still a big missing link, how we are going to do it. And as I'm realistic that it may not be quite as widespread or powerful as many other apps that are out there. If we are targeting it to specific questions, for example, let's do a catch and release fishery analysis in this specific lake, and we get some anglers engaged into it and we get them to download the app, maybe that will be more successful. But we're waiting actually for some results of a funding which should come in the next few days. So if that's successful, we will have more money to try and sort of promote the app a bit more. We'll see what happens. So we're looking for everyone's help in this. Thank you. All right, and the next talk is from Catarina Silva. She's a Nature Research Center researcher, but she's joining us currently remotely from Portugal. And she will talk about the machine learning methods, very interesting also analysis, how we could use data for. Okay, hi Catarina. You have to unmute yourself. Yep.
Hi, yes. How are you? Thanks. Can you hear me okay?
Yes, we can hear you. Start your presentation and we'll see if it all looks good. Yes, thank you. It's very good.
Good. Thank you, Asta. So, yeah, as Asta said, I'm a researcher at Nature Research Center working with Asta. And in this talk, I will start with some background to the problem we are trying to address with our work, which is the lack of data in recreational fisheries. And then I'll briefly present the results of two sub-projects we have been working on, which in general aim to make the data from fishing apps and social media potentially available and useful for science. So in the first project, we developed the framework for automatic fish species identification. And in the second sub-project, we are exploring techniques for estimating the fish sizes from images. So it is estimated that more than 80% of global catches from fisheries lack the essential data and resources and infrastructure for stock assessments to be performed. And contrary to commercial fisheries, as you've heard here before, where catches by country have been documented by the Food and Agriculture Organization for a while, only a few recreational fisheries catches are reported. And recreational fisheries continue to grow in popularity, and they have important well-being and economic benefits, but they can also threaten fish stocks. So, and also the environment, but the impacts often remain unknown because it's still considered data poor. But how can we make more information or data available about these fisheries? Well, the first thing we can use is citizen science data, as you've heard from Asta before. So large quantities of images and their associated information have been collected by nature enthusiasts. And these citizen scientists not only helped generating large data sets, but they also help promoting awareness and social engagement. So, and this has been occurring for some time now in areas such as biodiversity conservation and pollution observation. And for recreational fisheries management, citizen science would be especially powerful because it could improve our understanding of the health of fish stocks and also enable collaborative research, which has been shown to have clear benefits around the world, in particular in artisanal fishing settings. And so currently there are a lot of large quantities of data being collected every day, easily and cost efficiently, via mobile technologies, via fishing apps, as you can see in this image, for example, and also social media. But this data is not yet available for science. So we urgently need to use or create new tools and ways of extracting this data and use it for science. And with this large amount of data, there are, of course, a few challenges associated with analyzing it, and that's where artificial intelligence plays an important role. So the field of artificial intelligence has already revolutionized different areas, such as weather forecasting and traffic management. And AI and computer vision applications, they can be integrated with fisheries data and offer a great opportunity to transform fisheries management. First, because it allows the rapid processing of large citizen science data sets, and including automation of species, but also fish measurement potentially. But the integration of AI into fisheries management has been very limited. And as you can see in this image, the number of publications relating AI to fisheries is still very small per year, with only 40 papers per year. And also these studies are conducted mainly in commercial fishery settings. So because of that, often the tools and scripts are not openly shared to the community. So their application is limited. So there is a need to develop open source tools and apply this AI technology to recreational fisheries data. So the first sub-project I'm going to present here is about the automation of species identification from images. And we have developed a framework using open source code and software. And this pipeline, you can find it available on our project's GitHub page here. This pipeline it has a variety of applications, and the different components and scripts can be used for species identification, but can be also modified for other research questions. And just briefly, in general, our framework is divided into 3 main models and 6 different steps. And it includes important data pre-processing steps for the sensitive data filtering. As you can see in the first image here, for example, we used a pre-trained model to identify human faces and then place a bounding box and hide or just create a black area to hide the image, the face, therefore protecting the sensitive data. And then also in the next model, to accelerate the process of manual annotation of images, we also use a pre-trained model to detect the fish in the image. And this way, the annotation expert saves time because it doesn't have to go through all the images. For example, there are a lot of accidental images that are uploaded to fishing apps that do not have any fish. So some of these steps accelerate this manual annotation process. And then to demonstrate the implementation of this framework and its potential use for recreational fisheries research, we conducted a pilot case study, a small study to automate the detection of these 6 species, which were the most common images uploaded to a smartphone fishing application. So the bream, the perch, carp, bass, northern pike, and pike perch. And these are the images, the number of images we had per species. We also applied a data augmentation technique, which consists of transforming the images to increase sample size. In this case, to diversify the positions of fish, so they appear almost always in the same position. And we apply the vertical and horizontal flips in the images. So we increased the sample size by 3 times more. In the end, we had around over 4,800 images to train and test the model. And so we tested different model architectures and a combination of parameters. And this is the best model we trained with an overall accuracy of 91%. And this here is a confusion matrix, what we call, and it's showing the values of predictions. So on this axis, we have the true labels. So the actual species that are in the images, and here the predicted labels, so what the model predicts what species are in the images. And if you look at the diagonal, these are the correct predictions. And you can see that for most of the species, the model is performing relatively well. It correctly predicts most of the images for the species, but for some species, it's still not performing well. And this can be due to, for example, a smaller number of images, excuse me, or the amount of variation in fish positions as well, or the quality of the images, which are some of the factors that can influence the performance of these models. And so you can find more details about our framework and our study in this preprint. And we also have this paper in review for the Sustainability Journal. And I think very important takeaway from this study is that we show that the scientific application of this framework and its utility and potential for scalability, we show that with a relatively small number of images per class or per fish here, we use around 200 images per class, a model with a reasonably high performance can be developed quickly and with minimal resources for a small number of classification classes. So even though artificial intelligence applications still require a background in programming and computing, as new libraries and tools are being developed, the programming aspects can be overcome, can be streamlined. And this new approaches also require a lot less computational power and less amount of data needed to train and apply image classification models. So these new approaches that are using pre-trained models. When comparing to traditional approaches. So this enables smaller research groups around the world to use these tools, which was not previously possible. And you can also find more all the code, the scripts on this framework on our GitHub page. And we will be releasing an online course soon based on this framework, which is an introductory course for image processing. And so the second project I will present here is a little bit more challenging. With this one, we aim to estimate fish size classes from images without a reference object. So here is an example of how this has been applied in commercial fisheries setting. Here in commercial fisheries boats, a camera is placed in a known position from the fish, the belt, where the fish goes through. And there's also a reference object, which is, in this case, the width of the bell here, the blue line. And with this information, we can develop a model that can very precisely estimate the size of the fish that go through here. But in the recreational fisheries data that we have from fishing apps and social media, that's not the case. We don't have a reference object. We have this type of images, a person holding the fish, most commonly. And so we started to explore some machine learning algorithms on this type of data to test the feasibility first. And we have hypothesized that we could develop a model that could use human morphometric data, such as human hands, for example, that the model could use it as a feature for reference, and therefore would be able to estimate the size class of the fish, not the precise size of the fish, because that will not be possible without a reference object. But if we have at least some information of the class of the fish, as you've seen from Asta's presentation, that's very useful information for estimating population status. And so to test these ideas, we first scrapped images from Facebook and Instagram, the social media, images that had a person holding the fish and information of the fish size. And so we used these 4 classes of fish sizes, so from 40 centimeters to 5 centimeters each class, and these are the number of images. So we had a reasonably good number of images per class, around 50. And we also applied the data augmentation technique that I mentioned in the project before. We did the horizontal and vertical transformation. So in the end, we had just over 600 images across 4 classes. And these are again, the confusion matrix, the results for the best model trained so far. And as you can see, the overall performance is much worse than in the first project on species identification. It's only 65%. And this could be due to different reasons. So the first important thing to mention is that we are not sure about how precise the size of the fish was measured and reported. And then, of course, we have a relatively small number of images per class, but still we see that, for example, in class 45, the model has a reasonably good accuracy. It correctly predicts most of the images. So then we did another small test with data from fishing app, the MyCatch Anglers Atlas. With this data set is slightly different because we have the precise information on fish size, because for each record we have a hero shot, that they call a person holding the fish, that we are using for the model. And we also have an image of the fish measurements that for validation, which we are not using in the model, but we are we have more confidence on the size results. And here we have slightly less number of images for most of the classes. As you can see here, we had 9 different size classes of 5 centimeters each as well. And then after image augmentation, we ended up with over 1,000 images. And these are the results of the best model we trained so far. So the accuracy is slightly better, 78%, the overall accuracy. And you can see that for some classes, especially the classes here that have more data, the model is performing relatively well, but it's still not good for these middle classes here that do not have a lot of data, a lot of images. So as we still need to test this further because we have tested it in a relatively small number of images. And we also need to test other AI approaches, such as object detection, which is different from image classification, as we are doing here. And but in conclusion, in this sub-project, this challenging task of developing a model to estimate the fish size from images, it might be possible, but we need more data for this. And we, as Asta mentioned, we have started to collect some data in Lithuania. We're using the app, the Fish Size Project app. But we also would like to expand this project to other regions because these models could be applied to any fishery setting in the world, really. In that sense, we are actively looking for collaborations on this. So as Asta said, if you have data, we will be really interested in collaborating and developing such useful tools for fisheries management. And with this, I will end my talk. And thank you for listening. If you have any questions, please let me know.
Okay, the microphone here. Okay, thank you, Catarina, very much. Very exciting talk. I must say that I only saw these last results yesterday about the much larger number of sizes. And we had this idea like 2 years ago. Can we estimate the size of the fish from a picture like that? And people were telling us it's not possible. Like, because people are holding fish either close to the camera, far away from the camera, you will not be able to do it. That's not possible. But it actually seems that it might be possible, that, and it's only a very small number of images so far, 550 per class. I mean, if you think about Google AI, they're using millions of images. So I think if we had maybe 500, I think that would be really possible. Maybe we can go even further because we have so much data of people holding fish photographed like this, where we have no size. If we could tap into this data, that would be a huge potential. So if there are any questions online or in person here? We might need to talk the microphone because Catarina will not hear it. So Justus has a microphone here. Actually, wait a second. I just have a little...
Hi. Thanks again for a very interesting and scientific presentation. And my question is, like, haven't you tried, like, I'm like registered in many Facebook groups, you know, where the anglers are sharing their what they caught. And haven't you tried to scan these groups for the pictures? Because usually there are a picture and the size and the weight is everything there. So maybe this would be a great, great data.
Yes, we did actually. What Alina and Augustus were spending a lot of time doing, but this just takes a very long time to extract this data from social media. You know, downloading images and then the text that is next to it. It's not a very automated process, so it's very manual and very time consuming. And that's what we did from the first the results that I've showed, that the model didn't perform so well. But again, it is we need to be cautious with those size measurements because we don't have a proof that those are correctly measured. with small changes in the position of the fish, you can have a few centimeters of difference. And if you are using that in the model, you are just generating confusion. So if you don't have precisely measured fish for the model, that's even more important than the number of images, I think. If you have very precisely measured fishes and a smaller amount of images, the model will be able to distinguish between the classes better than just a huge amount of data. So that's the challenge, really. It's to have very good data quality for training the model. And then after that, as Asta said, if we have a good quality model, we can use that to extract the information from all of those images from social media that are even with the size information, but we can, using the model, I would say it's more efficient to extract this data, than manually. Yeah.
Yes, because Alina and Augustas can witness to many hours spent browsing through social media and reading through people's comments, trying to find that size of the fish that people posted and so on. So it's a lot of work, actually. It's not automated, yeah.
Yes.
Any more questions or discussions or other comments? So again, thanks a lot. I
think we have online one. I'm not sure. Sorry.
Oh yes, is there an online question? Yeah, you might be able to. I don't see Zoom chat at the moment, so if there is a.
Hello, here is Jan.
Yes, Jan. Okay, you can turn your camera on, Jan, so we can see you.
Well, the organizer has stopped it.
Okay.
So I cannot, but
Yes,
it's not so important. I'm not as nice as Catarina. Maybe just a note. Well, we managed to get in touch with this large angling competition that is happening in Lipno, and they are sending the images of every captured fish to some server, and in the same time they are measuring them. So that could be kind of ground truth data set. They have like 2,000 fish every year with the photograph and the real measurement taken, of course, by the angler. But you can use it as a training set. Theoretically.
The question, Jan, do they have people in them? Because I think this model specifically works when someone is holding the fish, because the computer actually uses the distance to whatever. Not just like, if you have just fish, a picture of a fish on grass, I think that wouldn't work.
It's not on the grass, it's on the boat usually, but there might be not a person, but for the next year, we may ask them to put a person there.
Yeah. Thank you. Yes, that will be really, really useful information. We'll keep in touch then. Thank you.
All right, so thanks a lot for all the online participants, and please, as I said, you can check all the findings of our work are available and will be available even more on our website and sif.lt or in Lithuanian lydekai.paliepus.lt. And so there will be papers there and models and so on that we have actually presented. And keep in touch. So see you later then. And then we're moving to the YouTube stream will end. We will end up we'll have a Lithuanian version in the afternoon. Bye everyone, online. Dėkui už anglišką dalį. Dabar kviečiame visus pietauti. Pietus prasideda 12.